Hi, team. If you're confused by how resources are allocated for your Atom queue, you're watching the right video. I'm going to briefly take you through how resources are allocated to your Atom queue in a cloud environment today. So we'll start on the shared queue server where we see a number of different resources assigned to the shared queue server, which is your Atom queue. The fields we're going to pay attention to are your memory allocation to a queue, your disk usage, these three parameters. Um, First of all, your memory allocation is the memory that the entire JVM allocates to the Atom queue. This is set to 25%. This 25% is out of the entire JVM heap space. So if we look at our startup properties on this particular cloud, the controller JVM has about a gigabyte allocated to the heap. Of that, 25% is allocated to the Atom queue overall. Each queue itself gets about 1% of the within the pool of 25%. So in this example, we have a gigabyte allocated of heap to the JVM, about 250 megabytes is allocated to the Atom queue itself, and of that 1% per queue, meaning for each cloud attachment, if we look at our queue management server here, each queue, this queue here would get about 1%, this queue would get 1%, et cetera, et cetera. All right, so back down to our final parameter, which is the disk space allocated to save or persist your queue messages, and this is about 100 gigabytes. This number here, this is listed in bytes. Now, how to check this information, if you look when you restart your cloud, if you look at the container logs, each node prints a message similar to this one, where you get a queue service, create broker, setting system limit, memory, queue memory, temp disk space, and store memory. So this number here, we'll take a look at these numbers. The memory itself is the tied to the 25%. So we see 25948,972, which is our number here, 259472 for the queue memory. That is 259 megabytes, which is about 25% of a gigabyte. That's space that the queue can use out of the entire heap space for the JVM. Next parameter is the queue, the memory per queue. So this was the total system memory. This is the memory for each queue. This is the 1%, 2594897. That is the second number. When we convert that to megabytes, that's about 2 megabytes. So each one of those individual queues can consume about 2 megabytes of space from the 259 megabytes allocated to the Atom queue. The next parameter is temp and store data. So these two numbers here are derived from this number. Now, this is 100 megabytes of file system space on the file share that is dedicated to storing messages from the Atom queue. This is a per node setting. So each node has 100 megabytes. Of this, though, each tenant or cloud attachment is allowed 10% of this overall 100 megabytes. So 10 megabytes for each tenant is allocated. So of this whole number, each tenant only gets 10%. Of that 10%, 70% is allocated to the actual store and 30% for temporary space for the queue to work. And that looks like these numbers here. You got the whole allocation, 100 megabytes, so it's about 107 megabytes allocated of disk space per node to the queue. This is the temp space that we saw in the log statement, and then 32 gigabytes for temp space, and then 75 gigabytes for your actual messages. So it's important to note that only 10% is allocated per tenant. Thanks again.